All right, last night's homework was on the law of sines, and then tonight's homework is the law of cosines. And it's not that difficult. Probably the most difficult part is you guys are going to memorize the formula. So, do we have questions on last night's homework? Tell me the numbers. Go.
Wait.
41, 33,
What? 49.
41.
Are these the word problems?
Yeah.
37,
But they gave you the
43, 47.
47. Didn't I do one of them for you?
Yeah, you did 39 for us.
37.
You did 39 for us. Wait,
You're calculating.
cross out.
I did 39 for you guys. Who said 39 then?
Kristen needs to. Sorry, you hear that.
Y'all sheets up. Shayna.
And
Asking absurd
thanks for
questions.
putting my book back to where it was supposed to be. Whoever it was.
That was on me.
Okay, what section are we on? 9.2.
One, that's right.
Okay, I'm not gonna get my calculator. You guys are responsible for the calculator. Okay, 37. Rescue at sea. Coast Guard Station Able is located 150 miles due south of Baker. Okay, here's Baker, and due south is exactly south, so that's Able. A ship at sea sends a SOS call that is received by each station. The call to station Able indicates that the ship is located from the north 55 degrees east, okay? So here's station, is it Able or Baker? Able. So here's the north. So from the north, you measure 55 degrees east. So it's gonna be like this, correct? That's 55 degrees. Okay. The call to station Baker indicate that the ship is located from the south 60 degrees east, so like that. So that would be 60 degrees. Okay, so this is the ship over here. How far is each station from the ship? Come on! And how far away? 150 miles. There we go. So they want you to find this and this. How far away from each station is the ship?
Oh.
Well, when do you use the law of sines? When you're given two angles. I know two angles, therefore I know the third, right? So what's the third angle? If this is 60 and 55, they add up to 115, therefore this angle has to be, how much more to get 180? You have a calculator,
65.
people. What? Okay, 65 degrees. So, if I want to find x, so this is how we do it. X over the sine of what angle? What angle is opposite from x?
55.
55. Remember, when you use the law of sines, you're always doing it with the opposite angle. Is equal to, the given side is 150, and what's opposite from the 150?
55.
65, there you go. So you use this equation to solve for x. So multiply both sides by sine 55, so x is equal to 150 sine 55 degrees over the sine of 65 degrees, and you just punch that in on your calculator and round off to 3 places. Not 4, Izuo, 3.
135.
Yeah, you guys got the answers in the back. You don't have to tell me.
Oh,
Well, anyway, you're gonna tell me on Wednesday, right?
yeah.
Is this speeches or is it?
No, it's just a regular quiz like this, this.
Does that have the code?
Except I'll give you the picture.
Does that have the code?
Yes, that's why it's on Wednesday. Otherwise, if it's just on the law of sines, you would have it tomorrow. Now, how do I find sine y? Y over sine, what's opposite from y?
60.
No, just look at the picture. 60 degrees is equal to 150 over the sine of, what's opposite from the 150? 65. And then if you multiply both sides by sine 60, you get y equals 150 sine 60 over sine 65 degrees, and then punch it in on the calculator. And now, this quiz, since some of you don't listen, if you don't round up to 3 places, I'm gonna take off points, Izuo. No, I already took off points for that.
How many points? 1?
Yeah, just one.
No,
Come on.
2.
No, I took off a blanket 2. Because if I took off one for each one,
Oh.
it would have been more. See how lucky you are? Okay, 41. Where's 41? Finding the height of an airplane. So look, they gave you the picture! Like that one, they didn't give you a picture, but this one, they gave you the picture. So it's like this. Honga, kachonga. Here's the airplane right there. There's the airplane. And then this angle is 40 degrees, the angle of elevation. And then over here, another angle of elevation is 35 degrees. And this is 1,000 feet, like this. 1,000 feet. What is the height of the airplane? Oh, by the way, number 37, did I just put 37 or 37A and B? Or just 37A?
I think you just said 37.
Okay, then there's a part B, right?
Hold on.
Can you guys do part B now, though? Do I have to do part B? Chief. Okay, part B, what does part B say? If a helicopter capable of flying 200 miles per hour is dispatched from the station nearest the ship, how long will it take to reach the ship? Come on! This is algebra 1.
Baker's closer, right?
Okay, first of all, so which one is closer to the ship? Able or,
Baker.
what's the name, Baker?
Baker is
Okay, and what is that distance? What is X? What did X come out to?
135.575.
135 point,
575.
Oh, 3 decimal places.
everybody got that? Okay, so if the helicopter can go 200 miles per hour, how long will it take to travel 135.535 miles? What equation do I use to figure that out that I learned in Algebra 1? Rate times time equals distance, right? Okay, do we know the rate of the helicopter?
Yes.
It's 200 miles per hour. The time is we don't know, that's what we're trying to find. And what is the distance that it must travel? 135.535. But, can I just use 3 decimal places right there?
No.
No, you gotta use all the decimal places. Because if you're gonna use a rounded value in another computation, you're gonna get rounding error. So you need to use all the decimal places. So,
141.
and then so to figure out the time it's gonna take, you just simply divide this number, 135.535 with all its decimal places, by 200, and that's how many hours it's gonna take. Yeah, Mashita? Yeah. I'm surprised you guys could do that. Okay, getting back to this problem. What is, how high is the airplane? Okay, what do we call it? You wanna call it H for the height of the airplane? How do we figure that out? Well, okay, before we even do that, just look at this triangle. Can I figure out, just think about it though. Just think about it. If I can just figure out either this side or that side, it doesn't matter which one, can't I figure out the height right there? Because I can use SOHCAHTOA. Because that's a right triangle. So your goal in this problem is either to find that or that. Okay, now, how do I do that? Well, I know 2 sides of the triangle, the 2 angles of a triangle. Do I know the third?
Yes.
What's 40 plus 35? 75, so how much more to get 100?
105.
This is 105 degrees here. So what do you want to find, this one or down? Pick one.
Right.
Okay, the right one, let's call that x. So x over sine, what's opposite from x?
40.
40 degrees is equal to 1,000 over sine, what's opposite from the 1,000?
105.
105 degrees. So multiply both sides by sine 40, so you get x equal 1,000 times sine of 40 degrees all over the sine of 105 degrees. Punch that in on your calculator. Okay, you guys are gonna do that. Okay, let's just call it box then, okay, whatever it comes out to be. Now, once you figure out what x is, now look, you got the right triangle right here. We're trying to find the height of the airplane, right? So look, here's the angle. Look at this right triangle. I have the angle. This is opposite. This is hypotenuse. Which of the 3 has opposite and hypotenuse in it?
So
So, yeah, so what is that?
Sine.
Sine. So the sine of 135 degrees, no, it's just 35 degrees, is equal to opposite over hypotenuse. So x is this thing, but you gotta use all the decimal places now. So the height of the airplane is equal to x times the sine of 100. Why do I keep writing 100? It's just 35 degrees. So whatever answer you got here, you use all the decimal places, you multiply it by the sine of 35 degrees, and that's going to be your answer. Okay, 43. Whoa, how come you guys just can't do these word problems? What's wrong? Pat needs to determine the height of a tree before cutting it down to be sure that it will not fall on a nearby fence. So here's a tree. The angle of elevation to the tree from one position on a flat path is 30 degrees. I think that's, should be longer, like this. Whoa, like that. Here's the height of the tree. That's what we're trying to find. And from a second position, 40 feet further down the path, so if I walk 40 feet this way, the angle of elevation is 20 degrees. Oh, farther, you dumb bull. Sorry, it's like this. That way, 40 feet that way is 20 degrees. What is the height of the tree? I think I might give this one on the quiz. I kind of like this one. Okay, how do I do it?
You can solve the.
Well, let me ask you this. If I can find what this is, then I can just use SOHCAHTOA to find x, right? Because you got a right triangle. See, you got to do two things here. So first step, look at this triangle right there. Look at this, that one right there. Do I know two of the angles?
Yes,
Well, this one is 20. If that's 30, what's this right there?
1050.
150, which of course makes this one up here 10, right? So now I can use the law of sines, right? So I'm trying to find this side of the triangle. So y over sine, what's opposite from y?
20.
20 degrees is equal to 40 over sine, what's opposite from 40?
10.
10 degrees. So therefore y equals 40 sine 20 degrees over the sine of 10 degrees. That will be punched in on your calculator. And then again, you're going to have to use all the decimal places. By the way, do you guys even know how to use the store button on your calculator? So you don't have to write down all the decimal places on your paper.
I think you said
The answer one.
Okay, now if you, no, not answer. Answer is the last thing it computed. Oh, I guess it would be this though, yeah?
Yeah.
But what if you needed like further, like more steps down the line?
No. Can you
Now, if you have a graphing calculator, look for this, either this button or this button. Try look.
Okay.
You see it?
E-
You know what this button does? It stores. So once you compute this number, you store it in either a letter from A through Z. Pick a letter from A through Z.
S.
Why S?
Because Shelby.
I was thinking A because that's the first letter of the alphabet, but you can pick whatever letter. So store it in alpha A or alpha B or alpha C or alpha D. That's if you have a graphic calculator. Now, if you just have a regular scientific calculator, I'm sure your chemistry teacher taught you, right?
No.
How do you store values? Who has a regular one? Let me see. Oh, you do have stone. And then you have letters. Okay, now if you just have a regular graphing calculator, I think, see, like on a graphing calculator, you can store numbers in A through Z. But if you just have a regular scientific calculator, I think if you just press the store button, that thing pops up right there. All right, let me try. See, what you do is you experiment. So turn it on. Try to type this in. Are you in degree mode? Okay, 40 times sine 20. Where's sine? Oh, this is barbaric. Sine, I forgot 20, divided by sine 10. Enter. Okay, did everybody get 78.784
That's wrong.
62024. Everybody get that?
Yeah.
Now, of course, if you want to, you can write it down on your paper with all the decimal places, but have your calculator do it. So what if you press the store button? Boom. Oh, so you have to pick a letter too. Where do you have the letters? Like A through Z. What do you mean you don't know? Well, me neither. I'm looking at it for the first time.
Does it have to be second?
See, it says, is there any letter on this calculator? Oh. Well, let's try it then. Enter. So every time you press this button, there you go, it comes up. Okay, now if you don't have that button, okay, let me see what you got. Oh, see, you can store it into A, B, C, D, or E. Pick one of them. Okay. And what do you have? Oh, you have a graphing calculator! Right here. Where's the arrow? Right there. This is, remember the arrow I just told you? So, you got this answer. That's not the answer I
No,
got.
I didn't.
Anyway, then you just press that and you pick a letter from A through Z. Anyway, it doesn't matter. If you can't find it, then just punch this in. Write it down on your paper.
How do you clear?
No need clear. Once it's in there, it stays in there until you replace it with something else. So you don't have to clear it. Don't worry about it. Okay, now, once we figured out what this is, how do I figure out x? Now, you look at the right triangle. Here's the angle. This is opposite, and that's hypotenuse. Again, we're going to use sine. So the sine of 30 degrees is equal to opposite over hypotenuse. So if we're trying to find that, you multiply by y, so x equals y times sine 30. Okay, now y is this number here. So like if you write it down on your paper, you can just put it over there. Or if you have a calculator now, how do you recall it? See, so if you stored it in, let's say, A, then what you do is you punch in A and then times sine 30. You get your answer that way. That way you don't have to write down all the decimal places. But come on, you're only going to do it for a few problems. Just make sure you use all the decimal places. Whenever you use a number in another computation, do not use a rounded value. That's when bad things happen. Okay, finally, last problem. And we still didn't finish early. 47. They give you a picture! I thought you guys cannot read the word problems, but if they give you a picture, you get to do. Okay, leaning tower of Pisa. Okay, this is the leaning tower of Pisa. It's leaning. Okay, this is obviously 184.5 feet. This is 123 feet. That's, what does it say? I can't even read it. 60 degrees. The famous Leaning Tower of Pisa was originally 184.5 feet high. At a distance of 123 from the base of the tower, the angle of elevation to the top of the tower is found to be 60 degrees. Find angle RPQ indicated in the figure. Where is RPQ? That's this angle right here. They want you to find that angle. Also, find the perpendicular distance from R to PQ. They want you to find the perpendicular distance just like the other problem. Okay, one thing at a time. Can I figure out what angle X is?
Yeah, no.
No.
No, you can't.
Now, remember I told you you can only use the law of sines when you know two angles of a triangle? Yeah, but Mr. Burke, I only know one. Yes, but you can use the law of sines as long as you know this angle is less than 90 degrees. That's like kind of a rule thing there. But can you see that it's less than 90 degrees? Because the leaning tower of Pisa is leaning that way, right? So since this angle is less than 90 degrees, we can use the law of sines. So here we go. So since this is the one I'm trying to find, what do I start with? I start sine of angle X over, what's the opposite side? I don't know the opposite side. So you know what I gotta do? I gotta find this angle first. Woo! No wonder I assigned this problem. So that means I gotta find this angle first. So sine of angle Y over, see the reason why I couldn't use an X because I don't know what's opposite from it. It's not given. Okay, so that's why I gotta find this angle. The sine of angle y over 123 is equal to, now since I know that angle, sine of 60 degrees over what's opposite from it? 184.5. So that's the equation you use to figure out what angle y is. So multiplying both sides by 123, sine of angle y equals 123 times the sine of 60 degrees over 184.5. Now remember, we're trying to find the angle. So once you punch this in on your calculator, you can get all these decimals, right? How do I figure out the angle that corresponds to that? We did this on the last test, people. If the sine of this angle equals that, how do I figure out the angle? You gotta go sine inverse. So y equals sine inverse all of these decimal places. So if this is the last thing you computed on your calculator, then you can just put answer, yeah? Sine inverse answer. Remember? Or just write it all out. You gotta use all the decimal places now. And then what do you guys get? Or do I have to get my calculator?
35.264.
I'm trusting you. 35.264 degrees. Everybody agree? Chung? Just nodding your head.
Thinking.
I want. This is not thinking. Just punch it in on your calculator.
Because you have point.
If I walk to my desk to get my calculator, you're grounded this weekend. Can somebody besides Noah verify that?
Yeah.
It is. Okay. But you gotta use all the decimal places. You can't just do 0.264 now. Okay, now, I got this angle over here. How do I get this angle there? Because that's the one they want. Well, you gotta add up to 180, right? So this plus this gotta add up to 180. So now if I know this one is 35.264, then
From 180.
and then subtract 60, right? So this is what you do on your see if you're smart, this is what you do on your calculator. You go 180 minus 60 minus answer. Because answer was the last thing you computed. That way you don't have to write stuff down. Okay, so that's what angle x is. That's what this is. So this is the new last thing it computed on your calculator. Now, once I got this angle, okay, that's the answer to part A. Now, part B, what is the vertical distance from the top of the leaning tower to the ground? How do I find this? What do we call this z then? Again, look, you have a right triangle, you SOHCAHTOA. So, now that I know this angle, what?
It's 84.
This is opposite. This is hypotenuse. Again, I'm going to use sine. So sine of angle x, which is the angle that I just computed, is equal to opposite over hypotenuse. So how do I find z? Multiply 184.5 times sine x. So 184.5 times sine of x. So what is x? X is the number that I just computed right here. So when you punch it in on your calculator, you can just do this. 184.5 times sine answer.
133.
Or if you want to write it out, but you got it. Does everybody understand? You got to use all the decimal places. So either you're going to write it out, or you're going to either use the answer or the store button on your calculator. But that takes practice. All right. So this is the plan for Wednesday's quiz. I'm going to give you 2 law of sine problems, and I'll give you 2 law of cosine problems. That should be good enough. So you have to prove to me you can use your calculator. And it's not gonna, and if I do give you a word problem, I'll draw the picture. That's fair, right? Yes. Okay. So today's lesson is the law of cosines. So again, what happens if the triangle is not a right triangle? That's when you use the law of sines and the law of cosines. But you just have to remember when to use each one. Okay? So, when did we use the law of sines? In fact, here, maybe we should write it out here. Law of sines. When do you use the law of sines? Here, I'll write it out. A over sine A equals B over sine B is equal to C over sine C. When you are given two angles and a side, and the side can be in between the two angles or not in between, it doesn't matter. Okay, now what is the law of cosines? C squared is equal to A squared plus B squared minus 2AB cosine of angle C. Notice that this angle is opposite from this side over here. Now, the book might give you three versions of the law of cosines, but it's the same thing. Like your book might write this: B squared is equal to A squared plus C squared minus 2AC cosine angle B. And then they'll also give you this one: A squared is equal to B squared plus C squared minus 2BC cosine of angle A. But no matter which one it is, if you just remember one, it's the same thing. This angle is opposite from this side right here. And then these two sides are the other two sides. See, this one is here, then these two are the other two sides. And then look, whatever two sides you put here, those are the two sides that go right there. Okay, so when do you use the law of cosines? When you are given all three sides of a triangle, or two sides and the included angle. That's when you use the law of cosines. Okay, let me do two examples for you. And again, tomorrow, you're just gonna make me do all the word problems. Is that what's gonna happen? Okay, let's say you have a triangle, and you know two sides. Give me some sides, 5 and 6, and the included angle, let's say it's 42 degrees. Okay, now, the lesson here is you want to be able to solve this triangle. In other words, find all the sides and all the angles. Well, the first thing you want to do is use the law of cosines to figure out this side over here. Now, how do you guys want to do it? Like, this is the way I do it. I just call this x. But Mr. Park, don't have any x's in this. It's only a, b's, and c's. But I like to call it x. I'll just show you. Okay? So I'm going to use the law of cosines because I know two sides and the included angle, right? So how do I find this side over here? I'm going to use the law of cosines. So x squared equals...
Wait, why don't you just put it as C?
Yeah, I know. I'm just showing you what I do.
Oh.
Were you listening 1 minute ago?
I know what the...
Equals 5 squared plus 6 squared minus 256 cosine of 42 degrees. You get it? See how? This angle is opposite from the side I'm trying to find. Since I'm trying to find that side, that angle is going to go here. And then these two sides are the two other sides, go here and here, and there and there. That's how I do it. But I guess when you first learn it, maybe it's easier with A, B's, and C's. Yes or no?
Yes.
What the difference? Okay, so let's say you like this one then. Let's say you like the first one. Because you're not going to memorize all three of them. You just memorize one of them and they all have the same form, right? So if you're going to memorize one, you want to memorize that one. So let's call this C then. Okay. You guys don't want to do it that way? Then of course, this is angle C. And which one, does it matter which one is angle A and which one is angle B? No, so like you can call that A and that's B. So of course, this is side A and this is side B then, right?
Mm-hmm.
So now, applying the law of cosines. C squared is equal to A squared plus B squared minus 2AB times the cosine of 42 degrees. Isn't that exactly what I wrote down, except I had an X instead of the C?
Yeah, but it's more.
Yo, Mr. Park, C is more understandable. Whatever! Okay, now, take out your calculator. Okay, you know what? I'm just getting my calculator ready. I'm done with you.
Put that on the ground, did. Listen again.
I'm getting a calculator. Wait, make sure I'm in degree mode. See, I wasn't in degree mode because I was using it for calculus. Calculus needs to be radian mode. Okay, so here we go. So what do I punch into my calculator? Now, if C squared is equal to this, then what is C? It's the square root of that. So C is the square root of 6 squared plus 5 squared minus 265 cosine 42 degrees. Okay, so here, let's punch it in. Square root 6 Now, when I see 6 squared, I don't punch in 6 squared on my calculator, I go 36. I just go 36, I can do that in my head, but knowing you guys, maybe you guys should go 6 squared plus 5 squared minus 2 times 6 times 5 times cosine of 42 degrees. Press the enter button and I get 4.05108756. You guys get that? And then I'm gonna store it in A. Or you know what, maybe I should store it in C because it's C. I think I'll do that. I'm going to store it in C. Where's C? I can't even read this thing. See, so now if I need this again, I just punch in C on my calculator and the calculator just plugs it in, so you don't have to do it. And if you don't like that, then just write it all down. Now, once I got angle C here, how do I figure out these two angles here? Can I use the law of sines? No. Remember, you only use the law of sines when you know two angles. But remember the problem we did? You can use it if you know for a fact that the angle is less than 90 degrees. But we can't really tell if it's less than 90 degrees or not. I mean, I drew a picture, but that doesn't mean the picture is accurate. So we shouldn't use the law of sines here.
So should we assume?
We use the law of cosines.
Should
Okay, so let's say I want to find angle A. You have to use the law of cosines, okay? Well, you don't have to, as long as you know this angle is less than 90 degrees, but we don't know. Okay? So we're just going to use the law of cosines, that's the better way. So, how do I start the law of cosines if this is angle A? Since I'm trying to find angle A. Which of these three has angle A in it?
The third one.
This one, see, angle A, so you have to use this one. So that means I have to start it with A squared, so I start with this one. A squared is equal to B squared plus C squared minus 2BC cosine of angle A. But see, you see this angle, I mean this side C? That's this. I have it stored on my calculator under C, so I can just punch it in. So can I figure out what cosine of angle A is?
Yes.
Okay, so what do I do? What do I do? What do I do?
36.
Okay, this is what, I'm just gonna show you what I do. Since I have a negative sign there, I'm gonna bring all of this stuff on this side. So 2 times 5 times C, cosine of angle A, is equal to, and I bring this one on that side, 5 squared plus C squared minus 6 squared, correct? Now, if you want to put the cosine on the right side, you can. I just like to have less negative signs, okay? And then if I just want to solve for cosine A, how do I get rid of this? You divide it. So cosine of angle A is equal to 5 squared plus C squared minus 6 squared, all over 2 times 5 times C. And again, if you're trying to find the angle, what do you have to punch in on your calculator? If the cosine of this angle is that, how do I figure out what the angle is?
Inverse.
Cosine inverse. So you gotta go cosine inverse. 5 squared plus C squared minus 6 squared, all over 2 times 5 times C. Now I take out my calculator and I just punch it in like that. So cosine, wrong button. Cosine inverse. Oh, I gotta use parentheses here. Oh, be careful now. You gotta put parentheses around here, and then you gotta put parentheses around there. You know why? Because your calculator does order of operations now. You guys understand what I'm talking about? Multiplication and division takes precedence over addition and subtraction. So you gotta be careful how you punch it in. So if you don't practice on your homework, this quiz could be disastrous. Okay, so parentheses, 5 squared, where's my squared button? Plus, see, I have this thing stored in C, so I can just punch in C squared minus 6 squared. And if you don't have it stored in, you just gotta put in the number with all the decimal places in it. Which is kind of a pain, but yeah, it doesn't take that long. And then divided by parentheses, 2 times 5 times C. parentheses, and then one more parentheses. Make sure that's right, press the enter button, and I get angle A is 82.3236762 degrees. So it was less than 90 degrees. So
Okay.
I could have used the law of sines,
Well, we cannot assume.
but we didn't know. See, that's the thing. Because what if it was like 107 point something degrees? Then that would be a pretty big error that you would get. And then of course, once you know this angle is 82.324 degrees, how do I figure out this other angle? Do I use the law of cosines again?
Subtract.
No, the three angles of a triangle add up to 180. So this is what I would do. Once I get this angle, I'm going to store it in A. That's what I would do. Well, that's because I have a graphic calculator, so I have A through C. But if you only have one basic calculator, there's only one. Then. So once I get this one, how do I get this angle here? I just go 180 degrees minus A minus 42, which is this one, right? So then I go 180 minus A minus 42, boom! And it comes out to 55.676 degrees. Now you can round it off. Okay, so that was the case right here. I see you were given two sides and the included angle. Okay, let's do this last case and we're done. I'm going to erase. Okay, I'm erasing it. I'll leave that if you want to see. No, I'm erasing. Okay, what about if you're given three sides of a triangle? Okay, here's a triangle. Give me some sides. 5, 6, and
9.
8,
no,
3.
10.
Oh, why not 9?
Okay, 9. Solve this triangle. Now you already know three sides of the triangle. You just have to figure out the three angles. Okay, so which angle you want to do first? Okay, why don't we give them labels then? A, B, and C. Pick one angle. It doesn't matter. Pick
C.
one. Okay, angle C. This is the angle I want to find first. So of course this means this one is C, this one is A, and this one is B. Correct? So which of these three am I going to use? Which one has angle C in it?
First one.
That one. Okay, so using the law of cosines, C squared is equal to A squared plus B squared minus 2AB cosine of angle C. See how, like again, see the 9? This angle is always opposite from it. And then the other two sides, 6 and 5, see how 6 and 5 are there and there? Okay, so this is what I do on my calculator. This is what I like to do. I bring this on this side. 2 times 6 times 5 cosine of angle C is equal to, take the 9 squared and put it on that side. 6 squared plus 5 squared minus 9 squared. Okay, so cosine of angle C is equal to 6 squared plus 5 squared minus 9 squared divided by 2 times 6 times 5. Do you guys actually want to compute it or just leave it like that? Let the calculator do all the work.
Let it do the work.
Okay, and then since I'm trying to find the angle, what do? Cosine inverse. So you gotta go cosine inverse of so angle C is equal to cosine inverse 6 squared plus 5 squared minus 9 squared all over 2 times 6 times 5. And again, just like the last problem, when you punch it in on your calculator, you gotta put parentheses there and put parentheses there now. Okay, here we go. Let's do it. I can do this. You guys gotta be able to do it. Cosine inverse. Okay, so parentheses 6 squared plus 5 squared minus 9 squared, close parentheses, divided by parentheses, 2 times 6 times 5, close parentheses, and close it again, bam! And you get 109.471220 degrees. See? It's bigger than 90 degrees. Cannot use the law of sines. Again. Anyway, you couldn't even use the law of sines because to use the law of sines you gotta have at least one angle and we don't know any angles. So You have no choice, you gotta use the law of cosine. And since I need all the decimal places, I'm gonna store it in C, since that's angle C, so I'm gonna store it in C. Woo! There you go. Now, I just gotta find another angle now. I know angle C now. I'm gonna either find A or B, which one?
B.
Okay, let's do B right there. So which of these three formulas do I use? The one that has angle B in it, this one. See, but then, like I told you, I don't memorize the formulas, I just memorize the form. So since I'm trying to find this angle, I start with the opposite side. So 5 squared is equal to 6 squared plus 9 squared minus 2, 6, 9. See how it's 6 and 9, 6 and 9? Cosine of whatever angle is opposite from the 5, which is the B. That's the way I memorize it. So doing the same thing I did over here, I bring this on this side. 2 times 6 times 9 cosine angle B is equal to 6 squared plus 9 squared minus 5 squared. Divide by that, so cosine of angle B equals 6 squared plus 9 squared minus 5 squared, all over 2 times 6 times 9. So since I'm trying to find the angle, cosine inverse 6 squared plus 9 squared minus 5 squared, all over 2 times 6 times 9. And again, you gotta put parentheses, otherwise you're in big trouble. Okay, let's punch this in. Cosine inverse, parentheses, 6 squared plus 9 squared minus 5 squared divided by parentheses 2 times 6 times 9, close parentheses, and then one more, and then boom! I get 31.5863381 degrees. Did you guys get that? How come you guys, I don't see your buttons going. No, just wonder about it. Lee, did you even ever bring your calculator to class?
No. Yesterday on the test, or Friday.
Oh, yesterday you brought it.
Yeah.
Wonderful. I'm going to store this in B because that's angle B. See, so now this angle is in C, this angle is in B. So now, how do I get angle A here? Do I use the law of cosines again? Yeah, you can if you want to. But why? All three angles of the triangle add up to 180. So if I want to find angle A, what do? You just go 180 minus B minus C. Right? Okay, so 180 minus B minus C. Boom, and my calculator says 38.942444127 degrees, and now you round off to 3 places. If you're going to use it in another computation, Chun, you got to use all the decimal places. Woo! Now, yeah, so the law of cosines is a more complicated formula than the law of sines, but that's just the way it is. Okay? And then tomorrow we got to learn the last thing.
Law of tangents.
No, although there is a law of tangents, we're not going to learn. I'm not going to even tell you what it is because just worry about learning this first. Okay?
Law of Cosines.
So this is basically this whole chapter. What happens if the triangle is not a right triangle? You have to use the law of sines and the law of cosines. If it is a right triangle, then you just use SOHCAHTOA. But in real life, most triangles are not right triangles. Alright, I'll just leave my calculator out because I'm going to use it for the end of class. Okay, we are done. Class ends in 9 minutes. And what do we got this week? What do we got this week? Where are we?
Prepare this week.
See? So tomorrow is the last lesson we're going to learn. And then Wednesday's homework is the practice test. But we're not going to discuss it till, because we got no class.
Tuesday.
And then family fair, half of you might not even be here.
Wait, so our test is on Monday or Tuesday?
Wait, let me look. And then Monday's a holiday.
Tuesday.
No! Are you looking at this, Chun? Then we gotta discuss the practice test. And then no class again. And the test is on Thursday. We just got a plethora of no classes, and what is the meaning of this travesty?
Fair.
Whatever.
Mr. Park, nice back.
Yeah, if you show me your calculator. You better start bringing your calculator to class. I'm gonna take off 1 minus 1 for each button missing.